Okay, so today is the area under or in between two curves as far as antiderivatives go. Integration can be used to find these. I'm just going to show you a couple of examples, walk you through the process by which it's done, and we'll be using it later on for something else that we'll be working with. Let's get started. So the area under a curve, or the area in between two curves, as I said, is very, very simple. It does involve some calculations, and it involves us dealing with the definite integral again, where we needed to be able to plug in numbers and not worry about the c value. So for my first example, I'm going to graph y equals 2 times the root of x minus 1. Simple grade 11 graph. We know it looks something like this. And then I'm going to pretend that I want to find the area from x equals 1 up to x equals 5 underneath this curve, which also technically means it's above the x-axis, which is the y equals 0 line. So this can be found by just setting up the integral from 1 to 5 of 2 times that function It'll give us this shaded in area right here. To actually do the calculation, I'm going to move the 2 out in front this time as a constant. I'm going to do the antiderivative, which is 2/3 times x minus 1 to the 3/2. And instead of the plus c, I'm plugging in the 5, getting an answer, and subtracting, plugging in the 1. I'll make sure that you can see where these 1s and 5s actually come from, but essentially this ends up being 10.7 units squared. If my graph was measured off in centimeters, I could say centimeters squared. Okay, next example. I'm going to look a little bit more specifically between curves. So when we're doing that, what we just did is because that we used the line y equals 0, we didn't really take a look at it. But effectively, we took the antiderivative of the top curve and subtracted the antiderivative of the bottom curve, which in the last case was 0. Here, when I have my graph drawn, you'll notice that the y equals 0 line is above the square root curve in the first section from 1 to 2, and below from 2 to 5. So to be able to do this calculation, we have to do 2 pieces. Just reiterating what I've just said to everybody. So this then is going to be equal to the first piece, the zeros on the top, the square roots on the bottom, that goes from 1 to 2, plus the second piece, goes from 2 to 5, the square root is on the top, the zeros on the bottom. Then it's a matter of doing the antiderivative of each one. For the first piece, I calculate it from 1 to 2. For the second piece, I calculate it from 2 to 5. Just a little bit of math here, and as I did this, I was having some fun avoiding calculators to the best of my ability. The 2 sets of square brackets on the left of the plus sign are for the first antiderivative. The other 2 are for the second antiderivative. These simplify quite nicely to either regular numbers or thirds. I put it all together and, interesting, I get 4 units squared. They don't always work out to beautiful numbers like this, but it's kind of fun when they do. Next example. This one I'm not going to actually finish. I just want to make sure we understand how to set things up. So the first thing that I'm going to do here is say that here's my graph, x cubed minus 2x. And my other graph, I'm just going to do a straight line, which is the 1/3 of x. Again, there's two pieces in between the curve. I've colored them in yellow. For the first piece, the f of x curve, the cubic, is on the top. For the second piece, the line is on the top. So the question becomes, where do I go from? Well, we need to find the intersections of these two graphs. So what we would do is just take each equation and set them equal to each other. And we would algebraically solve for our value of x. We get that either x is equal to 0, which makes sense, they both go through the origin, or x is equal to the plus or minus square root of 7/3, which I would recommend converting into a decimal when you actually go to try and do a calculation of that type. So again, we end up with two different pieces. One of them goes from the negative square root of 7/3 to 0. The other one goes from 0 to the positive square root of 7/3. And as I said, you can do the calculation for that one. A little bit of homework for everybody. Page 454, 1 ACGI 2A. Page 461, 1 ACEL and 3A. That sounds a little bit trickier. And our dogs for today this time are going to be a beagle, a bulldog, and a chihuahua. Enjoy your afternoon.